Right, good morning. Dandaka promise to do a recording, teaching on kinematics as per your requests, Naika. So I want to get into this thing. So I was going through your syllabus, trying to look at it and see, could syllabus renyure O-level physics from ZIMSEC rinoda kuti tikudzidzisei chi when it comes to the topic here, kinematics. Anditika. So here we are. So kinematics I branch reku physics, ibazi re muti unonzi physics, rinoona nezve mafambiro ezvinhu risingatarise zviri kukonzera kuti zvinhu zvifambe. So basically in English we are saying kinematics is a branch in physics which looks at the motion of bodies. So basically it's the study of the motion of bodies without looking at the forces that are causing the motion. Right? So let's just take that down. Kinematics. So if you remember, kinetic energy inokonzeresa kana kuti energy inenge ine body iri kufamba kana kuti inokonzeresa kuti body idi ifambe. So has to do with movement. Right, so kinematics is the study of motion of bodies without looking at the forces causing it. Basically that's what kinematics is. Tiri study motion. Hatitarise hedu kuti changa chapushwa here, changa chadii. Ayo tingotarisa kuti pacho pachapushwa papo chafamba zvakadii nespeed yakadii munguva dzakadii. So basically in kinematics tine ma-parameters kana kuti tingangoti tine ma-physical quantities atinoita look into. Pane inonzi distance, right? Pane inonzi distance, pane inonzi displacement, pane inonzi speed, pane inonzi velocity, then finally pane inonzi acceleration. According to ZIMSEC, we are required to understand the definition of distance, the definition of displacement, the definition of speed, velocity, and even that of acceleration. Right? So we are going to define these things one by one. Tichibva tapa formula inoshanda ipapo. Right? So now, if you really check, makadzidza nezvema vector quantities, makadzidza nezvema scalar quantities, ane musiyano waainawo. Ma vector quantities, right, nema scalar quantities. So ma vector quantities takati ma quantities isusu anoita pay attention to magnitude and also direction. You get it? My physical quantities ekuti anoita pay attention to zvinhu two. They have magnitude, which is size, and they have also direction. So pa list yezvinhu zvatinazvo izvi, inonzi displacement is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity. On the contrary, takune rimwe divi, distance is a scalar quantity, speed is also a scalar quantity. So because they just consider magnitude and they don't focus on direction. All right, so let's just take that down for the purpose of notes. The scalar quantity, its magnitude only. Example, distance. Ndepimwe, speed, etc. We are going to look at Zakawanda. Then anonzima vector quantities. Vector anenge aine magnitude plus direction. E.g., for example, we have velocity. We haven't defined these terms, I'm aware, but we are going to define them. Velocity, displacement, acceleration. Akatowanda, we'll talk about them, etc. Indeed. So, now let's get into the definitions. She knows the distance now. What is distance? Let's have that. All right, let us continue. Let's start with distance, right? Let's try to understand what distance is. So let's say we have an object here at point A. This is point A. Then yofamba, yosvika pa point B. Right. Distance is the total length of the path. Let me highlight it. Total length of the path. Right, like this. That's been traveled by the object, irregardless of direction. Because distance is a scalar quantity, doesn't care about direction. So whether that she move at she doesn't look at that. Inongotarisa panauye kuti izvi ndo zvaitika pafambwa so much. So ngatiti distance ekudai so kutendera kwesoko yanga iri 20 kilometers. Distance becomes 20 kilometers. So let's define distance. Distance. All right, let me put this in this color. Distance is the total length of the path traveled by an object. An object, regardless of direction. Not paying attention to direction. Right, so we said distance. This is a scalar quantity. We talked about it just as magnitude only, so it's a scalar quantity. The SI unit of distance, SI unit, standard international unit, is meter, represented by small letter m. Right? So simbu inoshandiswa in physics, contrary, zvinopikisana nezvamakakura muchiziva. Distance is represented or symbolized using S. S, small letter s, azvireve speed, no, it means distance kana kuti displacement. You will see when we get to displacement. So S ndiye watinenge tichidhila naye kana tichitaura distance kwete small letter d zvamaita kuprimary. No. Kunoku we don't do that. So equation here distance now. Let's just pick a good color for that equation here distance. So that is also distance kana tichida kuiwana manje tinoti is equal to speed times time. So patichazosvika kuspeed, you will see that speed is represented by v. Speed ndi v, distance that ndiani ndi s. Then time is small letter t. So in other words, takuda kunyora equation e using my symbols s is equal to vt. Right? Tane equation yedu yekutanga. So this is about distance. Right. So we now want to talk about second physical quantity known as displacement. Displacement, by definition, is the straight line distance right, from one point to another including direction. So that means this thing is it is a vector quantity. So for distance, for displacement, ngatiti munhu ari panapa at point A, or a straight line rake to this point, which is B. Ngatiti pakareba 20 kilometers. It's a straight direction, straight. Displacement inenge afambwa nemunhu, the displacement is equal to 20 kilometers. But now displacement is not measured in kilometers because SI unit for displacement is also represented by S. So symbol, the S foot, just like distance. SI unit yake is meters again, symbolized by small letter m. So in this case, patata the displacement is 20 kilometers. Kana tichida kupa answer iri correct match, tinoita kuti is equal to 20 multiplied by 1,000, because 1 kilometer is equal to 1,000 meters. So 20,000 meters ndo displacement inenge yaitwa covered. Wapabata. So displacement iri concerned about power tangira ne power gumira. So to get displacement tinotarisa power tangira toona futi power gumira ndo kuti tione displacement. Let me give an example. Ngatiti isusu iri ground rebore. Alright. Ground rebore racho rakaita rectangle, regati draw rakaita square. Was ground rebore, it's 100 by 100 by 100. So upon 100 meters, apa ne 100 meters, 100 meters, 100 meters. So this is point A, this is point B, this is point C, this is point D. Munhu ngatiti ari kutangira panapa papoint A. Wotanga kufamba zvako iwewe Shalom. Uchienda wosvika papoint B, wodai so. Wosvika papoint C, wodai so. Wosvika papoint D, wodai so. Wosvika papoint A again. Distance yaunenge wafamba, kana tichitaura distance, because it's a scalar quantity haitarise zvona direction. Inotanga kuedda 100 is plus 100 is plus 100 is plus 100 is, so distance yafambwa apa it's 400 meters. But kana takutaura displacement now, displacement inotarisa pawatangira, yotarisa pawagumira. So watangira pana A ukagumira pana A. So as for displacement, hakuna kwawaenda, you were not displaced. So it's 0 meters because it's concerned about the direction. This is a vector, this is a scalar, but both are represented by S. And okay, let's get going. Third aspect that we want to look at, it's called speed. Wow. So per speed, by definition, is the distance, definition, distance traveled per unit time. Distance yafambwa munguwa, anditi mufambo wakavwa pane a specific time. So distance, so the fact yekutongoti patongonzi pair up, you should know that means, so speed is represented by V. V is equal to distance, which is S, divided by per unit time. Per means division, time T. So this is it. So my units are SI unit for speed. SI unit is meters per second. Meters per second, and this is a scalar quantity. It is a scalar quantity. Right. So kana usingade kunyorako kuti meters/second, maybe wada kuratidza kuti wakadzidza stere kunogona kunyorako kuti meters second to the power of -1. Usasirire -1, ukamusirira amenako meters to the power of -1. This is also correct. Right, ndizvo here. So the SI unit the SI unit is meters per second, and also the symbol is V. This is a scalar. So now if we want to find speed, ngatiti susu tine munhu ari pa point A kusvika ku point B pane 20 meters. Amanya 20 meters idzi ngatiti adzikava from point A to B in 3 seconds. Tikanzi titsvagirewo speed, V is equal to S over T. S yedu ndi 20 meters over T, which is 3S, 3 seconds. So our answer inoita chi 3 into 20, we know this is 6.67, so meters per second. This will be the correct speed. Naika, let's go to the fourth aspect, which is velocity. Velocity, all right, let me write it this way. It is rate of change of displacement. Kana kuti displacement and it covered per unit time zvese zvinoita izvi. So izwire kuti rate riri kutotaura kuti time kudaro, kangonzwa pese panongonzi rate kutotaura. So rate of change of displacement is how the displacement is changing per unit time. So velocity is also represented by v. Generally it's represented by v. V is the symbol, right? So tikada kuzogadzira formula v is equal to s over t, ndo formula yacho. SI unit ndiyo imwe chete, meters per second or meters/second, ndizo zvakangofanana, right? Ndo SI unit yachona. So velocity inenge itori concerned zvekurevesa with direction, right? So for velocity, even this example ngori straightforward, can apply, you can move from point A to B to D to calculate. This is a vector quantity. It is a vector quantity, right? All right, so let's keep moving. We want to go to the next concept. We are running a little late. Acceleration. Don't want this video to be too long. Acceleration now. Acceleration is change of velocity per unit time. Kana kuti unogona kuti rate of change of velocity zvese zvinobvumidzwa. Ukada kuti rate of change of velocity zviri correct. Ukada kuti change of velocity per unit time, so acceleration symbolized by a, small letter a. So a is equal to change in velocity, which is change in v with respect to time. So change in v now, because it's a vector quantity, it means pane v final and it minus v initial over time. Ndicho chinodaidzwa kunzi acceleration. So normally v final is represented by v, and v initial is represented by u. So zvakunyorwa ndo paunozoona zvakunzi a is equal to v minus u over t. And so it's a vector quantity. sazvikanganwe izvo zvakakoshesesa. So this is how it goes. So maybe just before we forget, we want you to know that SI unit for acceleration it's meters per second squared. Meters/second squared. Or you can say meters second to the power of -2. Don't forget that. Anditika musazvikanganwe. So now we want to give an example yemubvunzo. Mubvunzo unogona kuuya muexam wakati a car is traveling at 10 meters per second. It accelerates uniformly to 25 meters per second in 5 seconds. Calculate acceleration. So according to zvatadzidza, acceleration is equal to v minus u over t. So munhu unotanga kunyora information yese yapuwa. A car is traveling at 10 meters per second. That's velocity kind. So this is u because it's initial velocity. The velocity atanga nayo 10 meters per second. V 25 meters per second. Then t 5 seconds. So our acceleration then becomes 25 minus 10 over 5, which is 15 divided by 5, which is 3 meters per second squared. The acceleration yacho. Satopera unenge watotsuna so. Naika. Right. So this is it. Let's go to the next. All right. So this part yekutanga tapedza this part. Tada kuenda pa the second part pa equations of linear motion. So pane ma equations aripo anoshandiswa pakasiyana siyana that we want to look into. Tichiona 1 by 1. So equation yekutanga of motion, ZIMSEC does not require kuti muziye kuti dzinobva kupi, tofanira kungokupai, but tinoda kukudzidzisai kuti muone kuti dzinobva kupi, zvikubatsirei kunzwisisa pamunenge muchiita physics dzenyu zvakanaka. So equations of motion. Right, so equation number 1, yakanzi v is equal to u plus at. Iriko equation iyoyi inonzi v is equal to u plus at. Inofana kuzikanwa nemusoro. But I'm going to give you kwainobva. So isusu tati isusu acceleration is equal to v minus u over t. So iyi equation inobva pakuti tino multiply both sides by t. Kana chiti both sides by t tikuti left hand side by t. Left hand side in the irino LHS left hand side. Then right hand side in the ukuku. Right. So everything chiri ku right cho multiply waona t everything chiri ku left chomaplya na t. So you'd realize that after that inenge ya at ku left hand side, then kunoko t uyu na uyu anokanzurana, so inosara ya v minus u. Then tokutati isusu toda kuti isusu chi v aite subject of formula. So takadzidza kuti isusu china minus u chikaendawo kuchinosvika kunoita plus, saka chinobva chaita u plus at is equal to v. Ndo pakabva equation iyo yekuti v equal to u plus at e. So this is our equation number 1. Equation number 2 inonzi s is equal to ut plus half at squared naika. So now let's understand kuti inobva kupi. Iyi equation iyi inogadzirwa kubva pa principle yekutanga ndeyekuti average velocity, ngati tinoda kutsvaga average velocity, tinoti v, which is final velocity, plus initial velocity over 2. So whether what u plus v over 2 cannot v plus u over 2, zvese zvingori correct, handito? U plus v over 2 zvakangofanana naika. And isusu tinoziva kuti displacement is equal to average velocity multiply by time, because isusu takati s is equal to vt, velocity times time. So if you want displacement yedu is equal to average velocity times time, right? So panapa tasvika ipapo chinobva tachiziva kuti okay, let's now work with this. So s is equal to u plus v over 2 multiplied by t. But from equation yekutanga yatadzidza iyo, v equal to u plus at, tinogona kutosubstitute kuti s is equal to u plus v, taudzwa kuti v is equal to u plus at, so tinobva tati plus u plus at, right? So this is over 2 multiplied by t. So s becomes 2u plus at over 2, so this is multiplied by t. And it. So now isusu tinoziva kuti kana zvikanzi a plus b over 2 zvakafanana nekuti a over 2 plus b over 2. So we want to apply it panapa because zvinhu zviri under common denominator yakafanana. So let's have it. That s is equal to 2u over 2 plus at over 2 multiplied by t. So our s then becomes 2 na 2 vanochekana, novaita u plus at over 2 multiplied by t. So our s then becomes u times t is ut plus t times at, it's at squared over 2. And we know isusu kuti anything b over 2 zvakangofanana nekuti 1/2 multiplied by b. This is mathematics. So s then becomes ut plus half at squared. This is our equation number 2. So this is not required for you to know by ZIMSEC, but it gives you an understanding. We want to get to equation number 3. Third equation, inonzi v squared minus u squared equal to 2as. This is number 3. So number 3 manje inobva pakuti takati a is equal to v minus u over t, right? Tika multiply both sides na t panapa, ukunosara kusina ukobva kwaita at is equal to v minus u. Tobva tati aiwa a ndiye ngaamboendawo, so t over a equal to v minus u over a. Apa panagara pana 80, so a na a yonochekana, so t is equal to v minus u over a. So zvatinoda kuita manje ndezvekuti tinoda kutora iyeyu iyi t time is equal to v final minus v initial over acceleration naika. Tobva taenda nayo pane equation yatambotaura iyaye yekuti aiwa ka displacement is equal to average velocity times time. Anditika, so totora t uyu anditika tonomuisa pana t uyu, so becomes s is equal to u plus v over 2 multiplied by v minus u over a, right? So isusu toda kuti zvinhu izvi zvigone kuwadzana naika, zvinhu izvi zviri kumultiplyana, so s isusu toziva kuti kana zvinhu zvakadai so zvazvinoreva ndezvekuti it's u plus v multiplied by v minus u over 2as, because zviri kumultiplyana. And izvi tikaexpressa as ma-quadratic equations, ma-quadratic equations anoti u bracket totanga kuexpanda v minus u plus v bracket v minus u over 2as. U times v ndi uv, u times minus u, it's minus u squared, v times v plus v squared, v times minus u, it's minus uv over 2as, uv minus uv zvobva zvaburitsana. So tinosara tina s is equal to minus u squared plus v squared over 2as. I think I made a mistake somewhere. All right, let's wrap this and start somewhere. Pani pandaona kuti pari kukonzeresa confusion, okay? Let's start from here. Sorry for that. So tati susu t equal to v minus u over a and then tikati susu tovoda tora inonzi s equal to u plus v over 2 times t. So totora t ichichi tonochiisa apa. So s equal to u plus v over 2 multiplied by v minus u over a. All right. So S then becomes U plus V over 2 multiply by V minus U over A. So 2 times A talk to Z into 2A. Then padengapo U plus V, V minus U over 2A. So U times V into UV. All right, let me not do shortcut because this will confuse you. Let me just do it. So, zvinobva U bracket V minus U plus V bracket V minus U. So this is over 2A UV minus U squared plus V squared minus UV over 2A ichi neizvo kanzurana. So inosara S is equal to minus U squared plus V squared over 2A. Zvinobva zvazofanana. So it's times 2A times 2A apanochekana. Zvinobva that 2AS is equal to minus U squared plus V squared. So zvazvinoreva ndezvekuti 2AS is equal to V squared minus U squared. Equation yedu number 3 inenge yabuda. So you're also not required to memorize all this. Unofanira kungoziva kwama equation aya. Iyoyi number 2, number 3 ne number 1 kwasara imwe here. Right, so ndidzodzo equation dzaunofanira kunge munhu uchiziva. Ukatodaro zvinenge zvaita unenge uchinzwisisa zvauri kuita. Naika tanzwanana here. So if you have any questions, feel free to put the question in the comment section or ask me on WhatsApp. All right, I think that's fine. Tasvika kumagumo kwelesson redu ranhasi. We'll take it up from there another time. Thank you for tuning in. Like, comment, share, and subscribe. Share with the other students that they may also know how to go around these things. All right, goodbye.